Hello students. In the last lecture I was discussing about 8051 microcontroller pin configuration, and there I was discussing about port 0 pins, and I told you how to configure port 0 pins into input and output, that is by connecting by connecting a 10 kilo ohm resistor externally to the port 0 pins. We can configure it as input or output pins, and to configure it as an input pin we need to write ones to the port 0 pins, and to configure it as output pins we need to write zeros to the port 0 pins. Now if you see in this pin configuration of port 0, let's talk about the dual role of port 0. As you can see, this port 0 is also designated as AD0 to AD7, allowing it to be used for both address and data. So when connecting in 8051 or 31 microcontroller to an external memory, that is when an external memory is connected to a 8051 microcontroller, then this port 0 provides both address and data. So 8051 microcontroller multiplexes address and data through port 0 to save the number of pins, else all bits of this port 0 are configured as input or output. That is what I'm trying to say, is that this port 0 pins can be used for transferring the lower byte of the address. That is if an external memory is connected to the 8051 microcontroller, then port 0 pins can be used for sending the lower byte of the address of this external memory, as well as this port 0 pins can also be used for sending and receiving data. That is, these lines are multiplexed as address and data lines to save the number of pins. So this was the dual role of port 0 pins. Now let's talk about port 1 pins. Now these are the port 1 pins. So port 1 occupies a total of 8 pins, that is pin number 1, 2, 3, 4, 5, 6, 7 up to pin number 8. It can be used as input or output. This port 1 pins can be used as input or output. In contrast to port 0, this port 1 does not need any pull-up resistors. Like port 0 needs pull-up resistors to be configured as input or output, whereas port 1 pin does not need any pull-up resistors since it already has pull-up resistors internally. Now, as I've already told you, upon reset, when 8051 microcontroller is reset, then all the port pins, that is port 0, port 1, port 2, port 3, all the port pins will be configured as input port or input port pins. So same for port 1, that is upon reset, port 1 is configured as an input port, and if port 1 has been configured as an output port, then to make it an input port, again what we need to do, this port 1 pin must be programmed as such by writing 1 to all its bits. So let's see the code. So this is the code for port 1 pin. So in this code, port 1 is configured first as input port by writing ones to it. Then data is received from that port 1 and saved in R7, R6 and R5. You can see first what is done here. 55H is written, sorry, not this one. Yes, this is the code. Yes, for what is written here, what has been done here. First, FFH in hexadecimal format is stored in register A. So FFH in hexadecimal format, when converted to binary, what does it mean? It means 1111 1111. So when this 11111111 is stored in register A, the next step what is done here, this content of register A is copied to this port 1 pin. The content of register A is copied to port 1 pin. So what we are doing, we are writing all the pins of port 1 we are writing all the pins of port 1 in to be 1. So we are actually inserting 1 to all the pins of port 1, and we are converting this port 1 pins. Whenever we are writing 1 to the port pins, what does it mean? It means we are converting those port pins into the input port. So here also, since we are writing the port 1 pins to be 1, so means we are converting the port 1 pins to be to input port. The next step is, since the port 1 has been converted into the input port, the next step is get data from the port 1. Since it is the input port, get data from the input port 1 and copy it to the register A. In this step, now next step is whatever data is copied in the register A, it will get transferred to R7. Now after delay, again the next data whatever is coming in the input port 1 pin, it will get copied in the register A, and the content of register A will get transferred to or will get copied to R6. And then again after delay, whatever data is coming in the port 1 pin, input port 1 pin, it will get copied into the register A, and that data of register A will get copied in the register 5. So in this way, port 1 is configured first as an input port by writing ones to it. Then the data is received from that port 1 and saved in R7, R6 and R5 registers. Now moving on to the port 2 pins, as you can see, let's go back to the 8051 microcontroller pin configuration diagram. As you can see, the port 2 pins, this port 2 occupies a total of 8 pins, that is from pin number 21 to pin number 28. So these are the port 2 pins. It also can be used as input or output, and just like port 1 and unlike port 0, port 2 does not need any pull-up resistors since it already has pull-up resistors internally. And upon reset, this port 2 is configured as an input port, as I have already discussed. That is, upon reset of 8051 microcontroller, port pins will be configured as input port pins. Now port 2 as input, that is, to make port 2 as input, it must be programmed as such by writing 1 to all its bits. Let's see the code. So this is the code for port 2. That is what is done here. We are converting this port 2 to input port, and how it is done, it must be programmed as such by writing 1 to all its bits. And in this code, port 2 is configured first as an input port by writing ones to it. Then data is received from that port and sent to this port 1 pin continuously. As you can see, first what is done here, first we have stored this FF hexadecimal format number in this register A. That is, now register A is stored with this 11111111. Now this content of register A, as you can see in the next step, the content of register A will get stored in P2. That is, in all the 8 pins of this port 2, we are storing this data 11111111, means we are converting this port 2 pins into the input port. Now once the port is converted into the input port, what we will do, whatever data is coming to this input port 2, it will get stored in this register A, and whatever data is coming in this register is stored in the register A will get copied in the port 1 pin. So this is how the port 2 is configured first as an input port. The port 2 is first configured as an input port by writing ones to it, and then data is received from port 2 and sent to port 1 continuously. SJMP back means keep on doing the same process. Back is this label. SJMP means keep on doing the same process. Whatever is written with SJMP means these steps will be continuously repeated. So this is how port 2 will work. Again, there is a dual role of port 2 that I will be discussing in my next lecture. I am ending this class here. Thank you.